In this video, I'm going to go over sine and cosine, those trig ratios. Now at this point, we've already talked about tangent. So for sine and cosine, it's going to be very similar to what we did with tangent, just a little bit different in terms of the ratio that we write. So let's go over tangent real fast. So tangent of an angle theta is equal to the opposite side over the adjacent side. Okay, so hopefully you have that down. Now the sine of theta is going to be equal to the opposite side over the hypotenuse. Okay, and for cosine of theta, that's equal to the adjacent side over the hypotenuse. All right, now we're going to use these relationships to help us do some questions. Now in this practice, there are a lot of questions. So in this video, I'm not going to go through all of them. So please make sure you check Canvas for the key for the ones that I don't go over, okay? All right, so let's start with these first 5. So we've given this triangle, and the first thing I notice is that it is a right triangle with that notation. I also see that it has a 60-degree angle here, so we should know that this angle up here is 30 degrees. So this is a 30, 60, 90 right triangle. Now they're giving us this side length of 7 times the square root of 3, which is across from 60 degrees. So to find the side length across from 30 degrees, I'm going to take that 7 times the square root of 3 and divide by the square root of 3 to get 7. And then hopefully you know, to get the hypotenuse, we're going to multiply that smallest side of 7 times 2 to get 14. So now that we have that information, we can go ahead and find all of these trig ratios. So the sine of angle A, right, remember that's opposite over the hypotenuse, is going to be equal to, from angle A, the opposite side is 7 times the square root of 3 over the hypotenuse, which is 14. Now you should notice that the numerator has a 7 that's not in a radical, and the denominator is 14. So I can actually reduce that to get the square root of 3 over 2. Let's do the cosine of that same angle. The cosine of angle A is the adjacent side over the hypotenuse. The adjacent side for that angle A is going to be 7, and the hypotenuse is 14. This reduces to 1/2. Finally, the tangent of angle A is opposite over adjacent. So the opposite side is going to be 7 times the square root of 3 over the adjacent side, which is 7. The 7's cross out, so we have just the square root of 3. Okay? Let's look at these two last ones from the perspective of angle C. So angle C is going to change in terms of what I think about for my opposite side and my adjacent side. But the hypotenuse will never change, right? That's always across from the right angle. So the sine of C is also opposite over hypotenuse, but this time going opposite the angle C, I get the side length 7, and the hypotenuse is still 14. That reduces to 1/2. The cosine of that angle C is going to be the adjacent side over the hypotenuse, which is going to be 7 times the square root of 3 over 14. We already reduced this one earlier in our very first question of the sine of angle A. So reducing 7 over 14 gives me the square root of 3 over 2. Okay, let's keep moving forward. Notice I'm going to skip these, but check back with the key so you can see what those answers are. Now, in this part of the lesson, we're going to use the calculator just for a short while, just to make sure you feel comfortable finding the sine, cosine. There's no tangent here, but we'll just use the tangent function of these angles. All right. Key thing is I'm going to use Desmos here on my iPad, and we are in degrees for all of these. So when I use Desmos, I always make sure I click the wrench to make sure I'm in the correct one, right? So if you load Desmos on your phone or on your computer, the default is radians. So make sure you click degrees so you get the right ones. Okay. So this first one says the sine of 31 degrees. So I'm going to do functions, hit sine of 31, close it. Now because I'm in degree mode, this is going to be the sine of 31 degrees, which is 0.515 round to the nearest thousandths. It says nearest tenths. Let me change that. I'm sorry. Nearest tenth here is going to be 0.5 approximately. All right, so approximately 0.5. Okay, I'm going to do number 17, which is the cosine of 75 degrees. So the cosine of 75 degrees to the nearest tenth is going to be 0.3. All right, so we're going to get you guys to be comfortable with using the calculator and also not using the calculator, right, with this trig. Okay, let's do some more complicated questions. So number 20 says to solve for x. If necessary, round your answer to the nearest hundredth. Okay, so I notice x is across from my hypotenuse, right? So this is the hypotenuse side. Excuse me, my x is across from my 90-degree angle. There we go. So x is the hypotenuse. They give me angle B, all right? And they also give me this side length. So that side length, if I'm looking at it from the perspective of angle B, is the adjacent side. So I'm going to set up a trig ratio that uses the adjacent side and the hypotenuse, and that would be cosine. So the cosine of 17 degrees is equal to the adjacent side of 10 over the hypotenuse x. Now, when I'm solving for my unknown in the denominator, I'm going to go ahead and make a proportion by putting that cosine of 17 degrees over 1. Then I'm going to do the cross multiplying, get x times the cosine of 17 degrees equals 10 times 1, which is 10. Dividing both sides by the cosine of 17 degrees will allow me to isolate that x. And I am going to round to the nearest hundredth. So I need to type in 10 over the cosine of 17 degrees. So 10 over the cosine of 17 degrees, which is to the nearest, I believe, hundredth. So I have to look at the third number, tenths, hundredths, thousandths, look at the thousandths place, which is that 6, and I'll round that 5 up to a 6, so 10.46. All right, now when you write that, right, just do a quick little check. Is that hypotenuse larger than that adjacent side? It is. So if you're doing this and you get a number that is not bigger than one of the legs, then you know something is incorrect. Okay, let's find number 21. It says find the length of JH. So right here, JH. If necessary, round your answer to the near hundredth. Okay, so when I look at this, they're giving me that this is a right triangle. We have 35 degrees. I'm trying to solve for the side that is opposite, right? So this is opposite 35 degrees. And again, this is the hypotenuse. So I need to write a trig ratio that uses the opposite side and the hypotenuse, which is going to be sine. So the sine of 35 degrees equals the opposite side, which is I don't know, over the hypotenuse of 9. Now, when my unknown is in the numerator, I don't actually do a proportion. I'm going to multiply both sides by 9 because that will cross out the 9s on the right. And so my unknown will be 9 times 35, the sine of 35 degrees. This would be the length of JH. Okay, so I'm going to type into my calculator 9 times the sine of 35 degrees, 9 times the sine of 35 degrees, which gives me, I think, to the nearest hundredths, would look in that thousandths place, which is the 2, so approximately 5.16. So JH is approximately 5.16. All right, I always take a moment to think, does that make sense? It does, because 5.16 is not larger than 9. Okay, I'm going to skip a couple and go to the last section here. All right, there's a box here. We'll put some notes in. I'll put some right here just to show you that so far we have been given angles and we're trying to find missing side lengths with trig ratios. So we've been using sine, cosine, and tangent, right? And if you type into the calculator the sine of 82 degrees, right, this is giving you a ratio, right? So it's spitting out the trig ratio that would be equal to that. So if you notice in 24, 25, and 26, there's a power that says to the negative first power. So if you see sine to the negative first power cosine to the negative first power, or tangent to the negative first power. These are called inverse trig functions, which basically means that when you type this into the calculator, you know the trig ratio, and you're trying to find the angle, right? So like in this one, you're given the angle, you're trying to find the trig ratio. It's going to spit it out. But in these, you don't know the angle, and you already know the ratio. I guess I should write a ratio. I'll make one up, right? I'll say 4/5. Okay? So this, if you type in sine to the negative first power, right? And we'll do this in a second. If you type in, let me do this again. This is incorrect. I apologize. So let's say you have this, start over here. Let's say you have this equation. The sine of some angle equals 4/5. What we're going to type in is we're going to type in sine to the negative first power of 4/5. And what this is, I'll highlight it. What this tells the calculator is, okay, if the trig ratio is 4/5, what angle in degrees, when I take the sine of it, would give me that specific ratio, right? So essentially, we're going backwards. That's kind of the long-winded way of saying when you type in sine, cosine, or tangent, you have the angle, you're finding the ratio. If you type in the ones that have -1 in the power, you're going the other direction. You know the ratio, you're trying to find the angle. Okay, hopefully I'll do a better job in class on that. Sorry about that. So let's try the 24 and 25. All right, so in the calculator, I'm going to type in sine to the negative first power of 0.45. So you hit functions, sine to the negative first power of 0.45. So this angle measure, let's say to the nearest degree, it says to the nearest tenth. So the nearest tenth would be 26.7 degrees. So 26.7 degrees. Doing the next one, cosine to the negative first power of 0.956. So cosine to the negative first power of 0.956. To the nearest tenth would be 17.1 degrees approximately. All right. Let's move on to do the last question. Number 27, find the measures of angles theta and alpha if necessary round to the nearest tenth. All right, so I look at this question. It doesn't matter which one you want to start with. I'll start with theta, it came first in this. So if I look at the triangle, this right triangle, from the perspective of theta, right, then they gave me the adjacent side from angle theta, and I know the hypotenuse. So I'm going to use cosine of theta equals the adjacent side of 9 over the hypotenuse of 11. So again, this is showing you that this is different than we did earlier. Earlier, we knew the cosine of we had the cosine of some angle, right? Like say it was 22 degrees, and we were trying to find for an unknown side length. So solving for an unknown angle means I'm going to write theta equals cosine to the negative first power of 9 over 11. Basically saying, okay, I know the ratio is 9 over 11. What angle, when I take the cosine of it, would give me that ratio? So I'm going to type in cosine to the negative first power, so cosine to the negative first power of 9 over 11, which tells me the angle to the nearest tenth is 35.1 degrees, approximately. So theta is approximately 35.1 degrees. All right. Okay, let's find our alpha. All right. So now I'm going to change colors so you can see it's different from alpha's perspective. From alpha's perspective, it's still the hypotenuse, always the same. But looking at 9 from alpha's perspective is the opposite side. So now I'm thinking about what trig ratio for opposite and hypotenuse, and that would be sine. So the sine of alpha is equal to 9 over 11. Now the work's going to feel very similar, right? Alpha equals sine to the negative first power of 9 over 11. But because we're going to be typing in sine and not cosine, it's going to give us a different angle measure here. All right, so sine to the negative first power of 9 over 11. There we go. So that gives us, to the nearest tenth, 54.9. Now, you may also, some of you while you're watching this, may realize is that if we already find that theta is approximately 35.1 degrees, we could actually find alpha by subtracting 35.1 from 90, right? Because this is 90 degrees. So alpha and theta have to be complementary, right? So I'm hoping that if we were to add 54.9 and 35.1, we would get 90 degrees, and we do. All right, guys, I know I didn't do them all, so check the key on Canvas. Try doing your homework. If you have any questions, come to us. Good luck.